Hello everyone, I am Dr. J. Dhanalakshmi, Assistant Professor, Department of Chemistry, Kamaraj College of Engineering and Technology. In this video lecture, we are going to see about electrochemical corrosion. Yes, before going to discuss about electrochemical corrosion, in previous lecture videos we had covered what is corrosion, how corrosion occurs, why corrosion occurs, and what are the factors which influence the rate of the corrosion, and corrosion control methods, including the first type of corrosion, because corrosion classified into two types. One is chemical corrosion, another one is electrochemical corrosion. So, the classification based on the environment. In previous lecture we had covered the first type, chemical corrosion, and what are the types of chemical corrosion. So, we had covered in the previous lecture. Now, we are going to see about what is electrochemical corrosion, or otherwise called as wet corrosion, and what is hydrogen evolution type and formation of hydroxide ion. Let us see one by one. Wet corrosion. Yes, dry corrosion, corrosion occurs absence of moisture. In wet corrosion, corrosion occurs in the presence of moisture. It is always called electrochemical corrosion. That is setup of anode and cathode, electrochemical reactions takes place. Yes. So, this wet corrosion occurs under some favored conditions. So, what are the conditions? See, the first condition, when two dissimilar metals are contact with each other in presence of an electrolyte, the corrosion occurs. So, consider this is a metal piece, zinc metal, it is coupled with a copper. So, bimetallic contact, this bimetallic contact is exposed into the environment have a moisture. So, this is an electrolyte contact with a bimetal. So, here corrosion occurs. This is for the first favored condition when wet corrosion occurs. And the second condition, a metal is exposed to varying concentration of an electrolyte. See, this is considered as a metal. This metal is partially immersed in an electrolyte. So, consider this metal piece, it not a bimetal, it is a single metal, that is homogeneous metal. But this homogeneous metal is partially immersed in an electrolyte, that is aqueous medium, and rest portion is above the surface. So, the concentration of oxygen is varied in this case. So, the metal, even though it is a single metal, not a bimetallic contact, here the concentration is vary, immersed portion and above the portion the concentration is vary. In this case, the wet corrosion occurs more favor. So, these are the two conditions under the wet corrosion occurs. Now, we will see the mechanism of wet corrosion. So, under the above condition, one part of become anode and another part become cathode. If it is an anodic part, oxidation occurs, right. So, dissolutions of metals occurs. In the another part act as cathode, that is reduction reaction occurs, which depends on the nature of the environment, that is corrosive environment. This corrosive environment plays a vital role. It depends on the pH value. The electrolyte plays a vital role. It depends on the pH value, whether the pH of electrolyte is lesser than 7 or exactly 7 or greater than 7. If it is a lesser than 7, the medium is acidic. Yes. So, if the pH value of the electrolyte or the corrosive environment is, the pH value is lesser than 7, the environment is acidic. If it is equal to 7, the environment is neutral, right. So, if it is acidic medium, what happens? If the environment is acidic, hydrogen evaluation occurs. If a medium is acid, hydrogen evaluation occurs. If a medium is neutral, exactly 7, or some cases slightly alkali, that is not exactly 7, it may be around 7.5 or 8, slightly basic in nature, alkali in nature, means the hydroxide ion forms occurs at cathodic part. So, the anodic part, metals dissolutions occurs, but for cathodic part it depends on the nature of the corrosive environment, it is vary, whether there is an acidic environment or the neutral environment. Now, we will move on to the hydrogen evolution type. See, the hydrogen evolution type corrosion, here the hydrogen actually all the metals are arranged in a electrochemical series. Already we know what is electrochemical series in the previous lectures. So, metals in above the hydrogen scale behaves the anode because it possesses a high negative electropotential value. Yes, the metals above hydrogen in electrochemical series, it get dissolved in acidic solution with the simultaneous liberations of hydrogen occurs. Say consider this is a metal piece, it is made by iron Fe. So, this iron is contact with the environment where environment have the medium as acidic means this dissolution occurs, metal get dissolved, this Fe convert into Fe2 plus and electrons released, right, get oxidized. Simultaneously the H plus from the hydrochloric acid, this H plus accepts the electrons released from the anode and get reduced in hydrogen. Let us see the mechanism in detail. Yes, at anodic reaction what happened? Already we have told iron dissolves. So, iron get dissolved in acidic medium. So, this Fe dissolves and with the liberation of electrons oxidations occurs. And at cathodic part the liberated electrons flow from the anodic part to the cathodic where the H plus ions present in the environment get reduced and convert into the hydrogen gas. This hydrogen gas evolution occurs. So, this is about the hydrogen evolution type corrosion. We will move on to the second type, formation of hydroxide ion type. So, formation of hydroxide ion type, before that all the metals except noble metals, all the metals exposed into the environment, there is a film formed on the metal surface, oxide film is formed on the metal surface. So, that film, oxide films, however, if oxide films develops further, some cracks will come. So, the crack will come and that crack portion acts as anode. So, it is act as anode means the rest of the portions behaves cathode, right. How we can explain? Look at the picture. This is a metal surface and this portion, it is a oxide film layer formed on the metal surface because the metal is already exposed in the environment, it is contact with the atmospheric gases, the oxide film is formed on the surface, this exposed portion alone the film is formed. Now, what happens? If the film is furtherly develops, some cracks occurs, right. This crack portion acts as anode. So, once it is act as anode, the dissolutions occurs means loss of electrons takes place. Look at the reaction, ion dissolves, right. This iron piece dissolves and convert into Fe2 plus, oxidation occurs. At cathodic part, that liberated electrons flows from the anodic part to the cathodic part through the metal where the electrons are taken up by the dissolved oxygen, right. The oxygen is dissolved in the water, it is forms OH minus ions because this dissolves in water and takes up the electron released from the anode and forms hydroxide ions. So, both the Fe2 plus and OH minus ions, both the ions combine to form ferrous hydroxide, right. So, this is the corrosion for product and this is not the single step. If enough oxygen is present in the environment, this ferrous hydroxide is easily oxidized and continues the corrosion. Yes, it forms ferric hydroxide. So, look at the reaction, this is for the ferrous hydroxide, if enough oxygen is present in the environment, already have the moisture, so convert into the rust formation. So, this is about the hydroxide ion formation type corrosion. So, up to this, what is electrochemical corrosion? What is the mechanism behind the electrochemical corrosion and what is hydrogen evolution type and what is hydroxide ion formation type corrosions, right. Now, classification is over. Now, we will compare the chemical corrosion and electrochemical corrosion. I have listed very important points, differences between the chemical and electrochemical corrosions. See, the first point, chemical corrosion occurs in the absence of moisture, but electrochemical corrosion, it occurs in the presence of moisture. That is the first important difference. And the second point, it is due to the direct attack of gases on the metal surface, but where due to a setup of large numbers of anodic and cathodic reactions need. So, after that setup of anode and cathodic, electrochemical reactions takes place with the flow of electron, and even a homogeneous metal surface gets corroded, whether the metal is homogeneous or heterogeneous, metal surface gets corroded in chemical corrosion, but in electrochemical corrosion bimetallic contact is a condition and heterogeneous surface is essential. But single metals get corroded, but it is exposed in varying concentrations of an electrolyte. One part becomes anode and another part becomes cathode, right. And one more difference, the products, corrosion products accumulate in the same place where the corrosion occurs. But in the electrochemical corrosion, corrosion occurs at anode, while the products formed somewhere else, it is not in the same place, right. And next point, the chemical corrosion, it is self controlled, because once the metal is exposed, the film is formed, oxide film is formed on the metal top surface. So, it is self controlled process, right. And electrochemical corrosion is not a self control, it is a continuous process, because that films furtherly develops, cracks occurs, that cracks induce, act as the anode and propagates the corrosion. So, this is a continuous process, right. Ferrous hydroxides, if enough oxygen is present, it is converted into ferric hydroxide, right. And the last difference is it follows the adsorption mechanism, right. Adsorption mechanism, for example, formation of mild scales of iron surface, and it follows the electrochemical reaction, because already we have discussed anode and cathodic reactions takes place, flow of electrons in presence of aqueous medium. So, electrochemical reaction takes place. So, for example, rusting of iron. These are the major differences between the chemical and electrochemical corrosion. So, up to this, in this session we have covered the classifications of corrosion, particularly electrochemical corrosion is over, and we compare the chemical and electrochemical corrosions. That is all today's lecture. Thank you.